Okay, going to finish off this chapter, chapter 4. So this is cubic applications. So this is the last section of the chapter. So looking at cubic models and applications. Practical solutions which use cubic polynomials as models are likely to require a restriction of the possible values the variable may take. So this is called the domain restriction. The domain is a set of values of the variable that the polynomial may take, and we'll have a look at domains in later chapters. So just an example 18. So we've got a rectangular storage container. It's designed to have an open top and a square base. Okay, here's my container. It's got an open top and it's got a square base. Now dimensions, we've got x along here. X is going to be the same because it's a cube. And we've got h for our height. Pretty standard. So what we want to do is express h in terms of x. That's our first part. So the dimensions are, if we have a look at the instructions, so we've got the base has side length x and height h. The sum of the dimensions, the sum of the length, width and height is 48. So that can help us with part A, finding h in terms of x. So we can say x plus h is equal to 48. Now just rearrange h and 48, we'll have 2x take 48 is actually h. So that's part A. Part B. No, scrap that. X plus h equals 48. 2x plus h equals 48. Now we actually want to take x over there because that'll give us a positive h is equal to 48 take 2x. So that's part A. So part B, show that the volume of the container is given by V equals 48x squared take 2x cubed. Volume, formula for a volume is base, so the area of the base times the height. The area of the base is going to be x squared times the height. Now height is actually 48 take 2x. Expand the brackets. Take 2 times x cubed, and that's what we have. Okay, so we'll start with the volume, area of the base times the height. So area of the base is going to be x times x, gives us the area of the base times the height, gives us the volume. Area of the base is x squared times the height, which we worked out from part A. Sub that in, expand the brackets, and you get the answer. Part C asks to state any restrictions on the values of x that the values x can take. So we know because it's an application, x can't be negative. And the height can't be negative, so h as well. Can't have negative height or length or width. So we have x has to be greater than 0, and also h has to be greater than 0. And we know h is 48. Take 2x, again just sub that in. Now we can say 48 is greater than 2x. So x here, and so we'll have 24. So x has to be less than or equal to 24. So our restriction is going to be x is between 0 and 24. So that was part B, that was part C. Part D, sketch the graph of V against x for appropriate values of x. Given the maximum turning point has coordinates 16, 4, 0, 9, 6. Okay, start with your set of axes. Now we know that x can't be less than 0, so already we can cross out those, so has to start at 0. So this was our formula for volume. Finding the, well actually let's factorise that a bit first. So that's our formula for volume. Now x-intercepts, we find when v is equal to 0, so 0 equals x squared 48 take 2x. So either x squared has to be 0 or 48 take 2x has to be 0. So we have x equals 0. Again, it's a repeated point, so that's going to be a turning point. We have 48 equals 2x, so x has to be 24. So there's our 3 points technically, because this is a repeated point. So we start here, don't need to worry about the negative parts, and we have 24 over here. Now we know that 16, 4096 is a turning point. So 16 is somewhere over here, we'll say. So up here is going to be a turning point. So just connecting the dots is going to be looking like that, with our point up here as the turning point. This is 0 and 24. So that's part D, and part E says calculate the dimensions of the container with the greatest possible volume. So the maximum turning point is 164096. So this means that the greatest volume is going to be 4096. And that occurs when x is equal to 16. So what height does it have to be? Well, we've got our height formula, which is 48 take 2x. And we know the maximum volume occurs at 4096, which is at 16. So 48 take 2 times 16. Do that. So it'll be 48 take 32, which will give us a height of 16 as well. So the dimensions for which will give us the greatest volume is going to be when x is equal to 16 and h is equal to 16. So the length and width gives us 16, and the height is going to be also 16. And that's part E. And that's cubic models and applications. So have a go at the exercises. I'm sure there'll be more questions that come up through that. Thanks.